Hello and welcome to another episode of Carbohydrate discussion series. Today, Vivek will present 1,2-trans and regioselective glycosylation of multihydroxy sugars. Let's begin the session.
This paper is reported in Green Chemistry by so many authors is there like Zhaolun, Zhang and Wei Li. So, in introduction, the strategy for stereo and regioselective glycosylation toward multihydroxy sugar. So, in that case, this donor we need the selectivity like alpha and beta. In case of acceptor, we need this selectivity which hydroxy group is used for the attacking. So this stereo control factor and regio control factor we will discuss in this paper. So various selective reagent for stereo and regio control here, this like boronic acid and boron boronic acid and boronic acid, noble metal chloride, aminoboronic acid, and thiourea-based catalyst. But in this work, they use different strategy without any another catalyst. They used BF3 and THF. BF3 they use as an activator. So this method is cheap and this method is cheap, simple and metal-free reagent. No halogenated catalyst is using. Regardless donor configuration, they are getting very much selective and less protecting and purification because here we introducing this regioselectivity. They are also selectively doing glycosylation. So in generally for the selectivity of alpha beta, we use OSIL strategy. So in that case, some limitation is there, like formation of orthoester. When the orthoester form, the selective cleavage come in picture from because which side we cleave this orthoester. This is the very big problem in that case, and this OAC group is disarmed. So this decrease the reactivity of on glycosylation. So overcome this limitation, they used OVN protected donor. So this they did different reaction condition. In case of first, they use mixture of alpha beta. They got 91% yield and beta selectivity. In that manner, they use gram scale and they did with only beta, and different activator they also use like TMSO triplet and different solvent. But in case of BF3, uh, BF3 ether and THF, they got beta selectivity with good yield. This is the substrate scope they try for this mm, mm, reaction condition. So they use pyranose and furanose form. So in that case, all case they are getting trans product. We can't say they are getting alpha selective and beta selective because they are getting only trans product. Like in case of first, they are getting 1,2-trans means beta is more. In case of second, they are getting 1,2-trans and alpha is more. So like that, they did so many substrate scope. And second case, they change the second position protecting group. They use different protecting group. They got 1,2-trans product with good yield. Then they study the effect of acceptor. So they change the position of O. First they took C4, then C3 and C2. Like in that manner, they did the so many mm, synthesize so many substrate scope using effect of acceptor. Then to scope of regioselectivity and synthetic application of this reaction condition. So in that case, they took without protection of hydroxyl group. So in that case, this primary used as a acceptor, and in that case, this C3 is as a acceptor. So this methodology using this much this scope of regioselectivity, they make a synthetic application to synthesize this Enterococcus faecalis antigen. So for that they use 68 as a acceptor. They used his own methodology like BF3 THF. They got selectively beta, and then they again activate this 69 using TMSO triplet. They selectively got alpha because this is so in two step they got 70 like Enterococus faecalis antigen. So after this uh, reaction condition and substrate scope, they try to come out the mechanism of this reaction condition. So first they did two comparison like BF3 MEH and BF3 MEOs directly. So in first condition they are taking BF3 ether with methanol. In second condition they are taking only methanol. In both case they got 71 as a 1,2 trans product. So using this two condition they come out in both case this BF3 MOH is forming. So from here they conclude that this 72 in presence of BF3 this activate and forming the intermediate 2. This intermediate 2 come this intermediate 4 and like that in equilibrium. But in case of this transition state alpha and beta, in case of beta energy is less, so this making intermediate 5 beta given selectively 1 to trans. So they conclude here this TCA is forming this intermediate. In case of this anionic intermediate is forming, due to this they are closer to each other and they then easily attack of methoxide is possible. So here they trans presenting this transition state, lower transition state, and beta and a higher transition state of alpha. And from here, in case of THF, they show also if we are taking methanol BF3E2O, so this replace this ether and make this this BF3 methanol. So in conclusion, they without any extra catalyst, they got 1,2 trans product using THF as a solvent and active BF3 is a activator. Thank you.
Nice presentation. Hello.
Hello. Yes, Priya. Thank you.
Can you explain that mechanism again? Actually, I couldn't get it properly. How they are getting alpha, how they are getting beta here? Plausible method.
Yeah. So in that case, this is the transition state this alpha and beta.
Okay.
So this transition state is means that take a reference 0, and this is higher energy. So from this they are getting this alpha product means 1 to cis product. What why this is lower energy and this is higher energy? This is the case of this higher and lower energy. So my feeling this methanol and this proton of this position, they are repulsion each other. That's not that much repulsion because this methanol is this side and this H is this side, means this is rotating one. So this can approach from like that manner, repulsion is less. But here this methanol and this methanol, if this is not that side, this side, then this H and repulsion will create. So here more repulsion, that's why this is higher energy. And
Here is
second
repulsion
thing,
between methanol and
methanol and this one. If this methanol is not this side, this one, this BF3 methanol, if this side means rotating, then this H is creating repulsion. maybe they not explain in that manner. They give
Okay.
only this one and this, and conclusion this they are making a adduct like a intermediate anionic intermediate. This is closer to this one. That's why they are getting selectivity. They
Okay,
have,
so they only use the TCA method and only they
huh,
change the activator. Initially, we are using
active.
like TMS triplet or other activators are there
Huh.
for.
In general manner, ether is selectively give alpha product, but in that case only they are given beta product. They are written in paper in general fashion. This all ether give alpha product,
Uh,
but here this with BF3 with THF given a beta product means 1,2 trans product.
okay. And slide number 8. Now, why they are using 1 and 69 as a two different donors? Means derivative of donor, it's by the TCA both.
Yeah, so this method they've developed a method. In that case, beta selectivity is coming. But in normal case, with I told you in ether case only alpha selectivity will come.
Oh, that's why they want that
That's
compound as
why
alpha.
in second case they need only alpha. So use this one and this activator. In first case, both are same, but
pH is there, okay,
activator
phenyl
they
group.
changed only. This NH is different because they protected with this one.
Maybe that also have some role. Because in the same example, they could have shown like, okay, BF3 threat is using, they are getting beta. And TMS
Yeah,
triplet they are using with the same conditions, they are getting alpha. Actually, this difference should be required here. Then it will be a very good
maybe.
example.
But
Okay,
in case of
that the
normal
activator.
ether method, they got only
Mm.
alpha selectivity. So, but here you are saying why they protect this in place of and they used pH.
That maybe. I don't know. Yes.
Hello. Nice
Hello.
presentation, Vivek.
Thank you, Bia.
You go to the next slide, mechanism slide. See, what is the reason for choosing this 4,6 benzyridine protected donor only for the mechanistic study? Is there any mention in the paper?
No, no,
Okay, they didn't mention anything about that.
they did not mention anything. But
Oh,
this control the this change in conformation. Maybe that's why they use this this type of protecting group.
okay, okay, okay. So they have taken THF as solvent, right?
THF as a solvent.
If there is any other solvent, any coordinate diethyl ether, that also follow the same thing.
No, no, they
Mm.
in
So in
normal
any of their optimizations table, they have used any other solvent, ether solvent?
DCM they used. See
No, no,
here.
any ether solvent, I'm asking.
No, other ether solvent they not use
Diethyl
with
ether
the
they used, na?
same BF3 because ether is already is there na BF3 ET2H.
Oh, okay, 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 okay,
No,
okay,
Yeah.
no.
okay.
If you see 9 entry, there is ether, diethyl ether they have used.
But they use with TMS or TF here.
No, no,
Ha,
no.
okay. Activator
Entry
is
8
different,
and
but
no, no,
yeah.
entry 8 and 11, you see, both have used diethyl ether
But
only.
in that case, this give one line. They are saying with BF3, this is making
Huh?
BF3 adduct this BF3 OR negative. This closer means they are coming anion is closer. That's why they are giving react this selectivity. But in case of TMS or triplet, they are not maybe make adduct and come near to each other.
Yes,
No, no,
yes,
but
yes.
only diethyl ether they are using in 11 or 8. Only diethyl ether, nothing else.
No, they with this I think BF380 they are using,
Yes,
but
so TMS
Only
selectivity is not
BF3.
coming that much good.
okay, selectivity is not there. Yes,
Yeah,
beta, but 20 as one, it's good only, but
good
not
only.
only.
But in that case, this THF they are
Beta only
getting
they're
getting
getting.
only beta.
Okay, in THF, that's why they optimize THF further.
Yeah.
Actually, this glycosylation mainly depend on the acceptor plus donor plus role of both protecting group, then some functional group. So
Maybe this rotational, these things is more in diethyl ether. That's why this
Ultimately, the
ether case.
coordinating power will be different with the THF and the
Yeah.
diethyl ether. So since in the
mm,
mechanism they're telling that coordination happens with your THF, so that must be having some solvent. And another question, like you may know or not know, I don't know. Since it has been published in green chemistry, so is the
Yeah.
THF solvent is green solvent?
THF solvent is
no, not green.
not green solvent
No, no, no.
because
Then major problem is major solvent is halo solvents are I mean dangerous to atmosphere. Every people tell like that.
yeah, THF is
Maybe
not
instead,
a greener solvent, but the thing they are approaching, this is halogen free solvent. Yeah.
that's what I'm telling. So better than any halo solvents.
That's why they use, but and this metal, this reaction is metal free and halogen free.
Okay.
That's why they are
Halogen.
saying greener method. This is a greener method. No catalyst they are using, no metal, no solvent like which have halogenated things.
So when which in which year when this paper came?
25 only.
25. On top of that, if you see activating TCA with BF3 thread text is with the textbook old example, right? It has been using
Yeah.
from a long back. Only we don't use, if I'm not wrong, there only we were getting this thio migration more with BF3 thread. That's why people in our lab use TMS at reflect. But
Yeah.
they have taken that just with the solvent one, they have published it in chemistry.
Actually, they got the alpha and beta selectivity. That is major point. Otherwise,
Mhm.
there is not that much.
Yes, yes.
That
Okay,
is.
thank you.
Thank you, Bia.
Nice presentation, Vivek.
Thank you, Bia.
Good. I don't have any further questions
Okay.
because only I had same question in mechanism they had why they have shown this benzyline because benzyline protection always have some role in the stereo selectivity. But since they are getting alpha selectivity in other substrate also without benzyline protection, although for mechanism explanation they have taken benzyline protected donors.
Yeah.
So regarding that, they didn't commented anything, right, in paper.
Yes.
Okay. Okay. Good.
Okay, Bia. Thank you.
Nice presentation, Vivek.
Thank you.
Go to like next slide, 5. Next. They are becoming some in anomalic position OME. In that slide you go.
Which slide?
In anomalic position, they are
Huh?
preparing OME.
Mechanism slide.
No, not mechanism.
Which one?
In anomalic position, OME is there.
Huh?
If I forgot that
OME
slide.
at anomeric position.
Starting,
OME. Where
ah,
OME?
like those two reactions are there, na? In BF3
That is
thread
mechanism
and
Oh,
slide. You go to the mechanism slide. I
this,
will show you.
this one, nah.
this like
Yes.
like here this 71.
Yes.
That means they are going to use D71 as a donor. Means why they are preparing like OME in animal position.
And for come on conclusion, which adduct is forming with BF3, they did these two reaction with methanol. Methanol as a acceptor here.
Mhm.
So means this methanol is making same adduct like that in situ the reaction, and they are
Like
commercially available. They are taking BF3 here.
means why they are preparing OME. I wanted to know like what D71. OME. at anomeric position.
They are not trying to preparing OME. They are trying to conclude this what is forming inside the mechanism. For this, they are not taking glucose like methanol and this BF380 with glucose. In case of methanol, some carbohydrate compound they are not taking like commercially. So they use these two things for this synthesize this. They are not using further use. They are come to the
Okay,
conclusion
this
of this
It's like
this one. They are making.
BF3 thread
Yeah.
plus methanol or BF3
Yeah.
Actually,
methanol.
they are simplifying it.
Then they come
Yes.
point what is the forming inside the this reaction condition. So here you see this methanol and this adducted forming. Using these two conclusion, they come that point.
okay.
Yeah.
Yeah, thank you.
Thank you.
Vivek, I don't have question. Just one thing, where they have done the regioselectivity, the previous slide.
This one.
No, 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 next. Next. No, no, where they have done this regioselectivity, like they have used 2 TC donor.
Oh,
The
here.
trisaccharide.
This one is like, it's very much known, right? C3 will be more reactive than the C4 for the even galactose.
Yes.
So there is a no such role like for the way of activation or something like
Yes,
that. Or
this increasing the length of this paper, I think they use this regioselectivity because normal case, this selectivity
uh,
is normal in all cases, not only this case, but yeah, I think.
no, no, regioselectivity, this one is very much established there. It's not like
That's why I'm saying they increase the length of this paper and his own method, they use this same concept for this regioselectivity. See, this here, like this and this is more comparison to this is more reactive. That's why this is reaction. Here also secondary and primary will react only. We know
exactly. Yes,
in all cases. So why this one will react? So for means as a substrate scope, they use this method only, and using this conclusion, they conclude this synthesis of this 17.
right. Okay, okay, okay.
Yeah.
Thank you, Vivek.
This is not they optimize this like why this is reactive. They're not given like that. This is more reactive. This they used only substrate scope using previous one like primary is more anomeric, then primary, then C3, then C4 like galactose. They use same concept and they applied here only to validate this
I
concept.
think, I think what
Okay,
they have done in their case, they are getting alpha selective product. Sorry, beta selective product. That's why they have used. You go back to previous slide. So first donor one they are doing for beta selectivity, which they have developed in this paper, and this donor 69 they are using because it is known to give alpha selectivity and they
Alpha
need
selectivity.
alpha linkage. Most probably that's why they have done.
okay,
Because
okay.
this target molecule, whatever they are targeting, one alpha and one beta linkage is required. So
Yes,
after using two different methodology, they are achieving this target 79 that is related to this antigen Enterococcus facialis. Most probably they might have written in the paper.
yes. Now it's like clear because they have whatever they have developed, they have used the same condition in the first and
Yeah.
each of they are getting beta. Okay, Vivek, thank you.
Thank you, Via.
If you enjoyed this session, don't forget to like, share, and subscribe. We'll meet you in the next episode, next session. Thanks for watching.